The second theorem we're going to chat about here is the polygon exterior angle sum theorem. So this theorem reads that the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So for a pentagon, if you notice the picture on the right, every side length was extended, just like we did exterior angles of triangles, and created an angle with the other side that's adjacent to it and the extended side. So 1, 2, 3, 4, and 5, if you were to add all 5 of those angles together, you get 360 degrees. And this will be true for any shape. So you can figure out what the measure of one of these would be if you take 360 and essentially divide it by the number of sides that you have. So what would the formula be for the measure of one exterior angle of a regular polygon? Remember, regular means that all sides and angles are equal. So that would mean that if all of those angles are going to add to 360, if I just divide that by n, which is the number of sides, we get the value of each individual exterior angle. So 360 is going to be the total sum of the exterior angles. And if we divide that by n, which is the number of sides, we can get the value for an exterior angle. So if we put this into practice here, let's try this out on the next page. If you want to find the measure of angle 1, well, angle 1 is an exterior angle of a regular octagon. So just like we talked about before, if I take 360 and divide it by 8, since I have an octagon, that is literally going to give me my answer. And if you do that on the calculator, you get 45 degrees. So every single one of these angles in here is 45. What would the measure of an exterior angle in a regular nonagon create? Well, regular nonagon has 9 sides, so we're just going to divide 360 by 9. And we get 40 degrees. So as you go along with this, you can see that this formula is pretty helpful. If you wanted to name the regular polygon whose exterior angle measures 72, we can do a similar calculation by just saying that 72 equals 360 over n, and we can solve for n by timesing by n on both sides, and we get 72n equals 360. I can divide by 72 on both sides, and n equals 5. So this would create a pentagon. Now, as a reminder, this only works if you have a regular polygon. So only works when you have a regular polygon. The minute you throw in a polygon that's not regular, meaning the sides and angles are not necessarily the same length, that is when you can run into trouble here, and you can't actually measure all of these because each one will change based on the shape of that irregular polygon.